For the basic question, we want to put the lean body mass in list 1 and the metabolic rate in list 2. And once we have all these typed in, we can go to stat plot and turn stat plot 1 on. And then we can graph that and go zoom 9, and then it'll show us our scatter plot. And here's my drawing of the scatter plot. And then to determine the direction, strength, and form of the relationship, we can go to stat calc 8 for linreg. And then when we calculate that, we can see our R, which shows the strength of the equation, is about 0.876. This shows that the relationship between lean body mass and metabolic rate is strong because the R value is between 0.7 and 1, and it's positive because the slope is positive, and it's linear. For the advanced question, again, we need to go to stat edit and put in for list 1 the representative age, and for list 2 the median distance walked. And then to find the least squares regression line, we can go to stat calc 8 for the linreg again. And this is the equation for that. And the slope of this means that the relationship is positive. In order to find a residual plot, we go to y equals, and then to put in the equation that we just got, we go to vars 5, go over to EQ, and hit 1. And then we go back over to stat edit, and we go vars over to y vars, and then hit 1 and 1 for the function in y1. And we put in L1 in parentheses because we need to find the x value of L1. In list 4, we need to find the residual, which is the actual value we got minus the expected. And L2 are the actual values, and L3 are the expected. So we do list 2 minus list 3. And then I graphed this residual plot, and I found the points to be fairly scattered, which is normal for a residual plot, meaning that the relationship is strong, linear, and it's positive as well. For the AP question, we get a plot and some value for that plot with the least squares regression line on it. From the values we're given, we look at the coefficient for constant and the coefficient for seats, and we get that y hat equals 1136 plus 14.673x, with y hat being the predicted operating costs and x being the number of passenger seats. And for part B, we're given r squared, and to find r, which is the correlation coefficient, we need to take the square root of 0.57, which is 0.755, and anytime r is from 0.7 to 1, that means the correlation is strong. For part C, we need to see if 250 to 350, if the range of number of passenger seats from that range would fall in line with the line we're given, and it wouldn't, because the 5 points outside that data set are influencing the line strongly. And if you look at only the points in that range of 250 to 350, it would be a negative correlation, so that would not work for that.